In the previous class, we saw this topology. You saw me configuring some PVCs between R1 to R2 and R1 to R3. See, R1 to R2 is this, R1 to R3 is this. But what I have not done is R2 to R1. I have to do. So I'm going to say port 2. Port 2 has got 201. So I'm going to say 201. Connect back to port 1. One zero two. Mapping already defined. Okay, so there is no need of reverse. It is bidirectional. In the command line, we used to do reverse because it is unidirectional. So only two PVCs, R1 to R2, R1 to R3. Notice we don't have R2 to R3. I don't have between R2 to R3. What does that mean? It means it's not full mesh. It means it is hub and spoke. Yep. Okay. Now let's finish this basic configuration. Interface loopback 0 on router 1 has got the IP address 1111. And then interface serial 4/0 has got IP address 10.0.0.1. Now here we need to put encapsulation type as frame relay. You know why? Because you have a frame relay switch in the middle. So you say encapsulation frame relay. The default encapsulation type is HDLC. We switch to a frame relay. Done. Now let us go and check something called frame relay map. Remember, the DLCA number that I configured here means this is what called as DLCA number 102, 103. These two are DLCA numbers. These numbers can be learned here dynamically. Whatever you configure here will be learned here dynamically using a protocol called inverse ARP. But before that, let us go finish R2 and R3. Interface loopback 0. Interface serial 4/0. And okay, one more thing. What is that? Encapsulation frame relay. Encapsulation frame relay. Okay, done. Let's do it on R3 now. Interface loopback 0. Done. Now you will see the IP address of R3 and R2 and the DLC numbers dynamically learned in R1. You want to see that here? See? Show frame relay map. Oh, nothing has come. Give some time, it will come. What I'm trying to show here is on R1, you will see like 10.0.0.2 if you want to go, you need to send to DLC number 102. That's what I gave here. And then 10003, DLC number 103. The number I gave here is 10310. This will be dynamically learned in R1 now. So these two are IP address on R2 and R3, but you will find them in R1 dynamically. Let me show you. Look at this, like a magic. How R1 knows the IP address of R2, which is behind the frame relay, with the help of a protocol called inverser. This is frame relay. And this number, you know, I gave to frame relay switch. C102, I have given here. Now you see, for 3 also it has come, 103. It's learned dynamically. This is frame relay. On R2 also you can see the hub. Show frame relay map. To go to 10001, the DLC number is 201. That is the number I gave on this port. And if you go to router 3, show frame relay map. To go to router 1, 301. That's what I gave you. For that same 10001 on router 2, it is 201. For router 2, it needs to go to 201. For router 1 to go to this address, it has to go to 102. For router 1 to go to this address, it has to go to this number. For this router to go to 10001, it has to go to 301. For this router to go to 10001, it has to go to its local DLC number 201. This is frame relay, and frame relay is already good, ready. Now we need to test only the OSPF part. We are going to test the OSPF part. For that, first of all, I want to check frame relay ready. I'm going to enable OSPF. Interface loopback 0, IP OSPF 1. Interface serial 4/0, IP OSPF 1 area 0. Done. Show IP OSPF interface brief. You see, OSPF is running, no doubt. But they won't form neighbor. Let me also finish OSPF on R2 and R3. On interface serial 4/0, same command, IP OSPF 1 area 0. One more router. Done. Show IP OSPF interface brief. See, OSPF is running, but they won't form neighbor. Anyone knows why? This is not frame relay issue. I also showed you frame relay map. It knows very well. Frame relay knows how to reach the other end. So it's not frame relay issue. It is something related to OSPF. Can anyone say why I'm not able to see neighbor? You see, there is no neighbor. Show IP OSPF neighbor. No neighbor. It's not forming neighbor. What may be the issue? Let us see how many are in class today. Because it is non-broadcast. You see, let me show you. Show IP OSPF interface serial 4/0. If you go up, you see the network type is not a broadcast or a point-to-point. The network type is non-broadcast, dynamically decided. And there will be a DR-BDR. I told you there will be a DR-BDR. And timer will be 30 and 120. It is not 10 and 40. It is 30 and 120. Yeah? All right. Now, neighbors need to be manually configured. See, OSPF don't know the neighbor, but frame relay knows. Frame relay knows the remote router. This is frame relay. But OSPF only don't know. So if you tell OSPF, this is my neighbor, then using frame relay, OSPF can go and form neighbor. You understand the logic? So let's go to OSPF, router OSPF 1, neighbor 10.0.0.2, neighbor 10.0.0.3. Now, frame relay knows how to take the packet if packet wants to go to 10.0.0.3 and 10.0.0.2. See, the neighbor has come up. It is recommended to do on both sides. But I'm convinced to do only on one side. Why, you know? It is going to be a unicast anyhow. This guy is going and talking to this guy. This learns the neighbor. And to the neighbor, it will start sending hello as a unicast. So why I should go and configure neighbor again here? Not necessary, but some document will say it is recommended to do it on configure the neighbor on both ends. You see here also it is already neighbor. So check show IP route OSPF. You see this route is learned from R3. Why it didn't learn from R2? Show IP OSPF interface brief. I do have a network 10.0.0.2. Why it didn't come? Ping. I'm able to ping router 3 Lübeck. Why router 2 Lübeck is not learned? Let's do again interface Lübeck 0 shutdown. So okay. Clear. Okay, I know the problem. This is not full mesh. This is not full mesh. It is because of this DR-BDR issue. Okay, that is why we have to move to another mode called point to multipoint. I'm going to remove this neighbor which I configured manually. I'm going to remove these neighbors. I remove the neighbor. Now clear IP/OSPF process. Show IP/OSPF neighbor. There won't be any neighbor. It won't come also. This is not a full mesh. We need a mode which won't conduct DR-BDR election. What it is showing. It says loading to full. You know why? Router 2 and 3 already learned R1 as neighbor. With that, it is pinging and forming neighbor. So to get the right result, you should shut down the interface for a while. Anyway, this is also good. Wait, I did not show you the DR-BDR election. Okay, let me show you that. In this non-broadcast mode, show IP/OSPF neighbor, you will see two-way, two-way, See, we don't have a connection between 2 and 3. That is why it takes a long time. You see, BDR. Router 1 is a BDR. As of now. What we don't like is DR-BDR. We should not have a DR-BDR in hub and spoke. Only if it is fully mesh, it is useful. So what I'll do, I'll shut down the interface. So there is no neighbor. The default mode is non-broadcast. Neighbor need to be manually configured. We have removed the neighbor. No more neighbor. So let's move on to the second method. I showed you the timer also, 30 and 120. Whatever is needed, I have showed you now. We are going to move to next one. So the mode, interface serial 4/0 is IP/OSPF. Sorry, this is the command, IP/OSPF mode. No. IP/OSPF network type, point to multi-point. Boom. Now in this, neighbors are dynamically discovered. Right? So I'm going to copy this, put it on all routers. Do it on all the routers. Done. Now neighbors are discovered. There will not be DR-BDR. No DR-BDR. Let's see. Show IP/OSPF neighbor. You see, it's full state. There is no DR-BDR. Show IP/OSPF neighbor. No DR, no BDR. Priority is 0. And neighbors are dynamically discovered. And you see the routing table will also be good. You see, you're supposed to learn this too through OSPF. You are learning. This was not there in the previous mode. In non-broadcast mode, you need full mesh. Otherwise, you won't get all the route that is supposed to be there. Show IP OSPF interface serial 4/0. See, the timers are same 10 and 30 and 120. And the network type I have switched from non-broadcast to point to multi-point. In point to multi-point, no DR, no BDR. Just only the neighbors, adjacent neighbor. There are two neighbors. And you are able to ping from here to 2, which is the other spokes. It goes through the hub. If you want to trace route, you can trace and see it will go through the hub. Goes to 10.0.0.1 and then from there it takes a U-turn and then goes to router 2. 10.0.0.2 is router 2. Yeah, it's a big U-turn. Right. So far, 2 RFC standard NBMA modes we have seen. Now the third one is Cisco. What is third one and what is special in third one? Third one is point to multi-point non-broadcast. So far, we said this is what we have configured. Point to multi-point only we configure. Now when I add another keyword after this, non-broadcast. The best of this one, which is no DR BDR, and best of this one, which is neighbor need to be manually configured. That's what we are going to see. Yeah. Let us go do it. I'm just going to add another interface, one word, non-broadcast. Okay. I have said no more support for multicasting. I've said non-broadcast. So the neighbors have went down. Let's verify. Show IPO SPF neighbor, no neighbor. What about on router 2? Show IPO SPF neighbor, no. What is this? Shut down the interface for some time. Right, and also in router 3. Good. Okay. The neighbor should not come up dynamically. Show IP OSPF neighbor. It won't come. It won't come. If you sniff packet here, you should not see any hello packet going. See, Cisco HDLC, no, we have frame relay. This is Q933A. Q933A is a protocol that is running in between two frame relay devices. Q933A is one of the LMI type. LMI, Local Management Interface. LMI, Link Management Interface. Fine, and it's the part of frame relay, you see, frame relay. So now what I'm going to do, I'm going to configure the neighbor manually. Router OSPF 1, neighbor 10002, neighbor 10003. Now we will see, do you see hello packets? As soon as I put the neighbor, you can see these are all the hello packets. Do you see anywhere any multicasting 224005? No. No. Because it is point to multipoint non-broadcast. It's always unicast based on the neighbor address that you give. It is always unicast, and good thing is there is no DR-BDR. There is no DR-BDR. Let us now go and check the routing table. I did not configure on router 2 and 3. It is okay. It is okay. Show IP OSPF neighbor. You have a neighbor. Show IP route OSPF. You got the routes. So you can ping from here 2222 with the source 33333. Goes and takes a U-turn on R1 and goes to R2. Trace route. That's it. So these are the three main things that we should know. The other two are well-known story. Let's do. We're going to do the fourth one called broadcast. Under the interface serial 4/0, I will remove this one. I removed do show history. Okay. On R1, interface serial 4/0, sorry, router OSPF 1, no neighbor. I'm removing this because you know the fourth type is broadcast. It should learn neighbor dynamically. And the timer should be 10 and 14 broadcast. So that's what we are expecting. Show IP OSPF neighbor I should not see any neighbor anywhere. Show IP OSPF neighbor. No neighbor. Show IP OSPF neighbor. No neighbor. Now let us go enable the fourth mode called broadcast. When I enable fourth mode broadcast, in the Wireshark you will start seeing right now you see everything stopped. After 157th line, nothing except frame relay. This Q933A protocol is frame relay. Q933A வே இல்லையே ஏன் சொல்றீங்க? ஆமா, protocol original பேர் இதுதான், Q933A. This Wireshark is not showing it fully. Now, there is no OSPF packets, but the moment I go under interface, serial flow for snaps here, IP OSPF network type broadcast. Now you will see. You see, hello packets are going from router 1. Likewise, go to router 2. Interface serial /0. IP OSPF network type broadcast. Likewise, interface serial /0. Done. Now you will see neighbor coming. You see the hello packets are going to and fro, and you see the neighbor between 1 and 3 is formed. That's why you can see a unicast 1 and 3, 1 and 3, 1 and 3. I don't know what happened to 2. I can see 1 and 3. Between 1 and 2, still I don't see any. 1 and 2 is also coming here. Now let's go and see the neighbor on R1. Show IP OSPF neighbor. You can see there are 2 neighbors, and there will be DR because it is broadcast. And let's see the timer. Show IP OSPF. You can see 10 and 40 now. And there is a DR and BDR. And the network type is broadcast. Right, so this is same like a broadcast experience over non-broadcast environment. What is next? We are going to remove this and make it as point-to-point. But for point-to-point, remember, you should have multiple networks. Here, all 3 are in same network. Where we need point-to-point, if this one is not of same subnet, then you need 2 subinterfaces, one for 10, another for 20. So we will have 2 point-to-point sessions from R1 to R2, 1 point-to-point session. From R1 to R3, another point-to-point session. But when you configure subinterface, there will be also a frame relay issue. What is that? Frame relay right now running on physical interface. As a result, the map was automatically discovered. Show frame relay map. This map is auto-discovered. You know that. I showed you right in the beginning itself. Learned dynamically. This map will break. You know why? Because we are not going to have this physical interface. We are going to have sub-interface here. The reason is 2 different network. 2 different network. Can you put 2 different network IP addresses in one port? That is not possible. You need 2 different wire. But I cannot have 2 different frame relay wires. It is very costly. So we are going to do sub-interface. But when you do sub-interface, this discovery won't be there. So we have to do something manual. related to frame relay. I want you to ignore such thing. You are not going to work on frame relay. Let's do. As I said, R3 IP address gets changed now. IP space address 20.0.0.3 255 255 and I'm going to change the network type also. IP OSPF network type point to point. This is the last fifth type. Show interface serial. Show IP OSPF serial 4/0. You can see here I have changed to point and the timer is 10 and 40. Neighbors will be dynamically discovered. There won't be any DR or BDR. Likewise, I'll go to router 2 IP OSPF network type point to point. And then on R1 interface serial 4/0, I'll remove this IP address. You know why? We are going to put that in subinterface. So, creating subinterface. Interface serial 4/0 dot, I'm going to say 10 point to point. Without fail, you have to say point to point. Next. Encapsulation frame relay, not necessary. Because we have done encapsulation frame relay on the physical interface. So it's going to be the same encapsulation. IP address is 10.0.0.1 255.255.255.0. Yeah. Now let's do the other interface. Interface serial 4/0. 4/0.20 point to point. And then IP space address 20.0. All right, now let me show you the status. Show IP interface brief. You see here, the serial interface is subdivided into two, and it has got the IP address. It is shut down because the physical interface is down. Now I'm going to bring the physical interface up. I've said no shutdown. The physical interface still has got what? Frame relay. Show interface serial 4/0. Still I got frame relay. I got frame relay. All right. So forget about this neighbor. This is old one, expired neighbor. Now show IP OSPF neighbor. There is no neighbor. The reason why there is no neighbor, because I did not configure point to point. That is one reason. Interface serial 4/0.10 IP OSPF network type point to point. This is one reason why the neighbor didn't come. All right, on both the subinterface I said, but still the neighbor won't come. The reason is not OSPF. The reason is frame relay. You see, frame relay don't know where to send. Show frame relay map command. There is no map. The reason is you have subinterface now. The inverse ARP protocol, which works for frame relay to discover, is not working. So what we can do is we can manually configure frame relay map. Here I'm going to say frame relay map IP. No need actually. There is no need for this frame relay. Interface, no. Frame relay frame relay interface DLC number. Okay, the interface DLC which it needs to go is 102. That will take there 102. That's enough. Likewise, you go to the other sub interface, which is 20, frame relay interface del C 103. That's all. This is enough to form neighbor. Show frame relay map. Yeah, see, it is automatically taking point to point. But it won't discover the IPs of the remote. The reason is it's point to point. No need. Let me check here frame relay. Show frame relay map. This knows 201. What about this? Show frame relay map. So soon I'm expecting neighbor. Oh, OSPF is not running on the sub interface. So what I need to do, go to the sub interface serial /0.10 IP OSPF 1 area 0. Likewise .20 IP OSPF 1 area. That's it. See, point to point is for multiple subnets. Other 4 is for same subnets. That is the meaning what you learned. Check now. Show IP route OSPF. You can see this. These two loopbacks from R2 and R1. So R2 and R3. Show IP OSPF. You can see two neighbors. Now, if you go to route 3, show IP OSPF neighbor, you can see a neighbor. Show IP route OSPF. You can see the route which is behind network behind R2. I'm pinging from here, ping 222 with the source 333. I'm able to ping. Though you got multiple networks, because of the point-to-point relationship that you got neighbors here, right? One more time. Show IP OSPF interface. You can see here it is point to point. Show IP OSPF interface. It's point to point. Right, that's all 5 modes. Any question? Say no.